Alright, so today we'll learn the other method for figuring out, like, what if you have a degree of 4 or higher and you can't use a difference of perfect squares or a sum of cubes or difference of cubes. Okay, and we're going to learn something called dividing polynomials, and that's a method used to actually break down a polynomial into its factors. Okay, so the remainder theorem states this. The remainder theorem is just saying if x minus 3 is a factor, then 3 is a 0 and can be divided out of the polynomial. Okay, and that will help with synthetic division. First off, we're going to do long division. So I'm going to show you both methods of both long division and synthetic division. Okay, and you pick which one you like the best. Now, long division, okay, you can use long division in most everything. Synthetic, you can only use in certain situations. Okay, so let's say we had to do long division. So first off, it would probably be presented to you like this. Divide 4x squared plus 23x minus 16 by x plus 5. Okay. So straight off the bat, you're going to have your divisor set up like this. You're going to have x plus 5 right here. And then you're going to have 4x squared plus 23x minus 16. I'm spacing it out for a reason, so you'll see. Okay, so first off, I'm going to ask myself, how many times does, and I always look at the first term, how many times does x go into 4x squared? And it actually goes in 4x times. And where do I put that 4x? I put it right above the x. Okay, and then I multiply it. So this becomes 4x squared. So I go 4x times the x plus 5. That becomes 4x squared plus 20x. Okay, and now here's the tricky thing. I'm going to minus it. So I'm going to minus these two from there. Okay, so when I minus, I'm going to get 0x squared, and I'm going to get 3x. And it's going to be 3x minus 16. I'm going to bring down to 16. Okay, then I ask myself, okay, how many times does x go into 3x? And it goes in 3 times, so I put a plus 3. Okay, so I plug it in, or I multiply it, and I get 3x plus 15. Okay, and then once again I minus it. So I go minus both of these, and I get a negative 31. Okay, now that negative 31 is going to be a remainder, so it's negative 31 divided by parentheses x plus 5 is how I write it in this term now. Okay? Alright, and so I've actually successfully divided it. Now, if it was a successful factor, I would get a factor of 0. Okay, so that's pretty much straightforward what the remainder theorem is. Now, if I did synthetic division, and let's say I did the same exact problem. So let's copy, Control copy. Okay, here's how synthetic division works. Okay, what I do is I take that factor and I make it negative. So this is negative 5. Okay, and then I write out all the numbers up here. So 4, 23, and negative 16. Okay, now if I was missing a letter in there, I would put a 0, and I'll explain that later with another example. Okay, but basically what I'm going to do is I'm going to bring down the 4 first. Okay, and then I'm going to multiply it by -5 and then add it here. So this should get me -20. Okay, I add them and I get 3. And then I multiply again. And I get -15. And this gets me my -31. Now, when I write out my answer of what the answer is of being factored, I'm going to start here, but I'm going to go one less degree than what was started up here. So if that's an x squared, this starts at x. So this is going to be 4x plus 3 minus 31 divided by x plus 5. Okay? All right, and that works out to be the same answer as what I got over there with long division. Now, long division, you can do pretty much any divisor in here. You could have a 2x plus 5, you could have a -3x plus 5 to whatever. With synthetic division, you can only do it when the variable is all alone. In other words, there's no number in front of x. Okay? Okay, and I just remembered that is not correct. Okay? The remainder theorem is not correct. I actually wrote it down wrong. If you divide a polynomial p of x, capital P of x, of degree where n is greater than 1, and you divide by x minus a, then the remainder is what happened. The remainder is basically what happens if I took a and plugged it into the actual function. So that's the remainder theorem. So in other words, if I plugged in -5 in here, I would have gotten -31. If I would have plugged in -5 here, once again, I would have gotten 31 because it's the same problem. Okay, so that's the remainder theorem. It just helps you when you're given a function and then you have to find p of like -2. You can just plug it into the function and just get your answer because it's going to be the same. So, or you could do long division and get the same type of answer. Okay, so that's actually kind of cool. All right, now let's say we actually have a problem that we want to work with. Now, if I wanted to factor it fully, let's say I had x to the third plus 7x squared minus 38x minus 240. Okay, and then I also knew that a factor is x plus 5. Okay. All right, so if I wanted to actually do it, I would actually do synthetic division. I would put -5 here. All right, and I would put a 1, a 7, a -38, and a -240. Okay, so I have it all here, so I put a 1 here. I multiply it by the -5, and I should get -5 here, and I add them. This should get me 2. I multiply it by -5, and I should get -10. I should get -48. And if I multiply -48 by -40, or I'm sorry, -48 by -5, I should get 240. And when that comes up, I get 0. Now, what that is saying is that that's proving that that's a factor, that x plus 5 is a factor. But what I'm actually doing is I'm transforming this and breaking this down into x plus 5 times, and this is going to be the tricky part. Okay, if you remember, this term is going to be 1 less than this. So now I'm going to have x squared plus 2x minus 48. Okay, so now I've successfully broken down this trinomial that wasn't a difference of cubes or of square or difference or sum of cubes, but I've broken it down into a binomial and a trinomial. Okay, well, I'm sorry, this wasn't a trinomial to begin with. This was actually a polynomial. I just broke it down into a binomial and a trinomial. Okay, this is done. I don't need to factor this anymore. This can be factored. Okay, and I start factoring it, and I get x plus 5. And what times what is negative 48 but adds up to 2? I would, or positive 2, I would say x plus 8 and x minus 6. Okay, so I've successfully broken it down into its 3 factors. Now, if I had to solve this, let's say I had to solve this, I would obviously have this equal to 0. I would just set it up equal to 0, and I would find x would be negative 5, comma, negative 8, comma, 6. Okay, all right? So the other cool thing is that that's also my roots or zeros or x-intercepts. Okay, so those all match up with it. Okay, so now that I have all that, I can actually tell you what the factored form or version of this is going to be. Okay, but the sucky thing is I do need a factor, okay, to actually work this. All right, that's it for today and just talking about zeros. Thank you very much and have a great day. Bye.